Hello, good morning. I'm Raymond from Project GUHeat, and my presentation is going to be about the, oops, it's going to be about the output maps of the project, the tools we used in creating these maps, and I'll also be giving a brief demo on the usage of these tools. Okay, so unfortunately, the maps for Cebu are not ready yet, so I'll just be showing some maps, the same maps, same concept, but from a different site. So this one is from uh, a map of the air temperature in Lower Session Road in Baguio City. Actually, have three of these maps. One at 9 a.m., another at 1 p.m., and the last one at 5 p.m. So what can we do with these maps? Well, one thing these maps can be used for is to provide us with information for decision making. Let's say you want to conduct a greening project to help mitigate the effects of urban heat. One factor you can take into account is which areas would benefit the most from it. And as an example, if you look at the map here, these areas in the upper right portion have much warmer temperatures than these areas here. And what's that? Oh, and if you look at the other maps, you'll notice that these areas are consistently warmer throughout the day. So based on that, you can say that this area up here should be the site for the greening project. Of course, there's going to be other factors to take into account, but this is just an example. Okay, so here's another map. It's also by Project GUHeat. It's of the same area, Lower Session Road in Baguio City. This time, instead of just air temperature, we have the air temperature difference between two user-defined scenarios. Like the previous one is also useful in planning and decision making. And in this map, scenario one is the actual situation of Lower Session Road, while scenario two is the same but with less trees along the road. So we can see that here in the road where the trees were removed, the it has a relatively high positive value, meaning it got hotter when you remove the trees. You can interpret it as that. Uh, you can also do this for other scenarios like removing buildings or adding more buildings and stuff. Oh, so this one is actually of Cebu City. So this is an LST time series map of Cebu City. With this, you can see the trend of the temperature throughout the year. So we can see we have three. The LST was taken at three time steps. One at April, August, and November 2019. So we can see how the land surface temperature was the highest during April and got cooler as the months go by. So August it's cooler than April, and in November it's a bit cooler than August. Um, if you want a better trend, you want to see a more accurate trend, you can get more images of preferably the months in between. Uh, yeah. Okay, so now we discuss the tools used in creating the maps. So we have three main tools used in the project: the Google Earth Engine, the GUHeat Toolbox, and ENVIMET. So the first one is Google Earth Engine. Uh, Google Earth Engine is a cloud-based computing platform which also has access to a huge database of satellite images. So pros and cons. Like I said, it has access to a lot of satellite images. These satellite images, by the way, are free and can be accessed by anyone. So there's no need to download the images before processing. Also, since it's cloud-based, it does most of the processing on Google servers. And Google servers are most probably better than regular PCs. So excuse me, the processing times are usually much faster, and even a regular PC can do the processing and produce the same output. However, since it is cloud-based, an internet connection is required. And also, you need to know how to code in Python or JavaScript in order to make full use of it. You can use Earth Engine apps created by other users, but you'll still need to know how to code if you need to make any changes. And also, there are cases where an API update usually like breaks the code, and in this case, you'll need to know how to code to fix it.
Okay, so this is just going to be a short demo on how to use the Project GUHeat Google Earth Engine app. First, you have to open your browser, and in the address bar, you enter this URL. Then you press enter. So here we can see the GUHeat engine. It is an Earth Engine app created by the project. And what it does is it automates the land surface temperature computation using Landsat images. So to start, you first select what satellite you want to use. You can use Landsat 4, 5, 7, or 8. For this demo, we'll just use Landsat 8. And then you select whether you want to use day or night images. After that, you'll see that the app will load in this new layer. This layer just shows the Landsat tile footprints over the Philippines that are available. You can click any of these tiles to automatically set the path and row field here of the area that you just clicked. So since I clicked this tile containing Metro Manila, it set the path and row to 11650. After that, you can set the start and end date that you want to process. So for this demo, we'll just set the start date to January 1 and the end date to January 31. Then once that's done, you click Generate LST. So after a few seconds, the outputs should be loaded here. There we go. So as you can see, there are 2 dates available. You can also see the dates here in the list of layers. So we have one image that was taken January 4, 2019, and the other one was taken January 20. You can also turn these layers on or off if you want to check which image is better. Now to export, you can either use select on map the area that you want to export, or you can use view extents. So first, I'll show you what this does. So using view extent just sets the export area to the whole view extent, basically. But for now, we'll use select on map since we only need a small area. So once you click the button, you can draw a rectangle over the area that you want to export. Then you'll see that stored here as this layer called export extents. You can turn off some of the layers to make it faster. And then once you're done with that, you can click generate links. After a few seconds, it should show here we go, a list of download links here. So this image that we're showing right now is the one from January 4. So let's download that. So after downloading, you'll have this TIFF file. You can open this in any GIS software really. So let's open this in QGIS, and there you have it, an LST image. This is the one from earlier, the area that you selected earlier. That's it.
Okay, so next is the GUHeat toolbox. The toolbox is a plugin for QGIS created by the project as an alternative to Google Earth Engine. However, other than computing for LST, it has other tools included in it, like flare corrector, stuff. Other tools used by the project in processing stuff. So pros. It's it is relatively more stable than Google Earth Engine. Um, updates usually don't change much, especially if you're using a long-term release version. And also, it does not require internet access, so you can just download images when you have internet and then just process them after. However, since you're doing the processing on your machine, processing usually takes much longer, and it will depend it will depend mainly on your machine specs. And most probably your machine isn't going to be as powerful as Google servers, so yeah, it'll take much longer. For comparison, processing a single Landsat tile in Google Earth Engine usually takes a few seconds only, while processing the same tile on my laptop can take a few minutes. It might not be that big of a difference, but if you're processing a lot of images, those differences tend to pile up. Also, same with Google Earth Engine. You also need to know how to code to make plugins and also to do maintenance if in case anything goes wrong.
So now we'll be looking at the Project GUHeat toolbox. So after installing the toolbox, you can see it here in the menu bar of QGIS. So here are the available tools. For this demo, we'll just be using the land surface temperature. So we're going to be processing a Landsat 8-day image. There's only going to be one image, so we'll just set this to individual data. Like with the Earth engine, the GUHeat engine, you can also process Landsat 4, 5, 7 images. So first, you set the input path. This path is just going to be this folder. This folder contains the Landsat bands after extracting. So we set the input path to that. And then for the output path, you just set the path where the folder where you want to save the output. And for the output file name, you just put the output file name. You can also turn on show results to automatically load the output into QGIS. So let's turn that on and then you press run. So after a few minutes, you'll see the output image loaded into QGIS. You can now close this window. So in order to properly visualize the land surface temperature, you can double click the layer here and go to the symbology menu, and then you change the render type to single band pseudocolor. And then here in the band, you can select band 6, which is land surface temperature. So there are other bands that you can display, but for now, we'll just show land surface temperature. You can also change the color ramp if you want. And you can also change the mode here to make it easier to visualize. So we'll use quantile and you can increase or decrease the number of classes. Then you just click apply and OK. So there you have it. This is the processed LST image. The yellowish parts correspond to higher temperatures, while the purple and pink-ish parts correspond to lower temperatures. That's it.
Okay, so the third tool is ENVIMET. ENVIMET is different from the other two in that it is a simulation software. So with ENVIMET, you provide it with a model of the area. Usually this model includes buildings, vegetation, land cover, etc. So this image here is an example of the model. Um, the gray blocks represent the buildings, the green spheres represent the vegetation canopy, and the color of the surface represents the surface materials. So in this case, the brown orange surfaces represent soil, while the light yellow surfaces represent sand. He also provided with atmospheric parameters such as air temperature, humidity, wind speed, wind direction, And the software then takes all this data and it simulates the microclimate condition in the area. This simulation can then be used to analyze the effects of the structures and other objects in the area on environmental factors such as temperature, humidity, wind speed, uh, other stuff. So one of the outputs of the simulation is shown in this map. Also, another map of Baguio City, Lower Session Road. So in this case, the color represents the air temperature, while the arrows show the wind direction. So these are just two of the many available simulation outputs when you use ENVIMET. And I guess a few more announcements. The GUHeat toolbox and the GUHeat engine, which was presented earlier, will be provided during the closing webinar on August 14th. Soft copies of the maps will also be provided then. Probably by then they'll be ready. And if you have other concerns or questions, you can just send us an email. Send an email to projectguhit@gmail.com. And that's the end of my presentation. Thank you.